This is a lesson for 14-1, day 1. What you're doing in this part of the chapter is that you are classifying real numbers, all right? The open or close part is for tomorrow's lesson. So by classifying the real numbers, there are different types of numbers that we're looking at, right? There are something called natural numbers, whole numbers, integers, rational, irrational, and real. There is also imaginary numbers, but imaginary are the opposite of real numbers. And we're not going to talk with that because that is not a 9th grade topic. All right. That's really when you get into 10th and 11th grade math. So taking a look at natural numbers. Natural numbers are basically counting numbers. All right. If you think back to like when you first learned numbers in kindergarten, 1st grade, these are the numbers that you start with. All right. Little kids start with 1, 2, 3, 4, and they keep on going like that. All right. Those are counting. Those are natural numbers. That does not include 0. What includes 0 are whole numbers. Now, the way that I personally remember that whole numbers include 0 because they start at 0. Think of the O in whole. All right. Think of the O in whole. That reminds you of starting at 0, where natural doesn't have the letter O in it. All right. So O, remember whole, it starts with 0. So those are all of the natural numbers, 1, 2, 3, 4, 5, 6, and keep on going and going. But we start at 0 instead of counting at 1. So literally the only difference between natural and whole is that it starts at 0 instead of starts at 1. Integers. You know what an integer is. You've been doing these for a couple years now. Integers are both positive and negative whole numbers. So it's all of your negative numbers, all of your positive numbers, and 0, but not decimals. Integers are not decimal numbers. So -1, -2, -3, -4, -5, and you keep on going. 0, 1, 2, 3, 4, 5, 6, and you keep on going. Not decimals. A rational number. You have rational and you have irrational. A rational number is a number that can be converted into a decimal that either terminates means to stop, or repeats. All right. If you could use the repeating sign. So a decimal that stops is like 0.5 or 1.25 or 8.7. Those are all decimals that stop. As long as the decimal stops after the last number and doesn't keep on going on and on and on forever, that is a terminating decimal, which is rational. It could have 5 numbers after the decimal point. It could have 10 numbers after the decimal point, as long as it stops. A repeating decimal, you've seen repeating decimals before. For example, if you had like 1/3, if you can make 1/3 into a decimal, 1/3 is really like 0.3 repeating, 0.3333333 goes on and on and on and on and on forever. All fractions, any fraction that you make, pick any number, 5, pick any number, 8, 5/8, 5/8 is a rational number. It could be negative as well. If we had like -1/2 or -4/3, any fraction that you can make is rational. Percents, any percent is rational as well. So like 20%. Irrational numbers. Irrational numbers is a decimal that never ends and never repeats. So pi, they love this one on the Regents exam. All right, pi is the most common irrational number. They love all these questions on the Regents exam because they make for very easy multiple choice. It'll say which of the following is an irrational number. They might give you 1, 0, -1/2, and pi. So you would have to pick out pi. Pi is the most common irrational number. That is a Regents exam question almost every single year. Or the square roots of a non-perfect square. So for example, when you type in the square root of a number, if you got 8.7265 167,381, and it filled up the whole screen of the calculator, and it keeps on going. It's non-terminating, so it never ends. That's what that ... means at the end. And it's non-repeating. You can't use the repeating symbol anywhere. Now, you have to be careful on numbers that look like this. If we had like 7.122,333, 4444, and it kept on going ... at the end. That is not repeating. Yes, there is a pattern there, but it's not repeating. I can't use the repeating symbol, that repeating bar, over the top of it, because that repeating bar over the top of it, like in 0.3, that means that just the 3 repeats. If we had a number like 1.24 and the repeating sign was above the 2 and the 4, that's rational because the 2 and 4 repeats. That really means 1.2424242424. All right. Anything that's underneath the repeating sign repeats. All right. But you can't use a repeating sign here. Yes, there's a pattern, but that is irrational. Irrational are your really, really ugly decimals. That's a good way to think about it. It's your really, really ugly decimals. If you were thinking that pi, because in maybe 7th grade or maybe 6th grade, when you did like area of a circle or circumference of a circle, you use 3.14 for pi. 3.14 is not really pi. 3.14 is an approximation of pi. They were really rounding pi. Pi is not 3.14. Pi really goes on forever and ever and ever. They've calculated it to literally billions and trillions of decimal places, and it never terminates and it never repeats. So pi is not 3.14. It's a really, really, really long, ugly decimal that never ends. Real numbers. Every number on this screen is a real number, all right? The opposite of real numbers are imaginary numbers. We talked a little bit about that. That's when you take the square root of a negative number. That's an imaginary number, but we don't deal with that in 9th grade algebra. So what you're going to have to do today is sort of classify, and you will have one question on your quiz for this chapter that looks very similar to this. So what this is, first of all, you have 2 circles, all right? I'm looking at this big green circle first, all right? And I'm looking at the yellow circle over here with irrational numbers. So numbers, real numbers, because all of these are real numbers, because that's all that we're dealing with. They either have to be classified into rational numbers or irrational numbers. They have to be one or the other. So it's easier probably to pick out the irrational numbers. Well, when we do irrational numbers, first of all, I see this 0.122334444. Notice that it doesn't repeat and it doesn't end. It goes on forever. That's what the ... tells us. And you can't use the repeating sign anywhere. Pi, if you don't learn anything today, pi is the most famous irrational number. Pi is irrational. Also, when you have square roots like that, you need to actually calculate those, all right? So the square root of 25, is 5, all right? The square root of 25 is 5. Yes, it's technically plus or minus 5, all right? The square root of 0.25, all right? The square root of 0.25 is, I don't know, and I don't have a calculator here. It's like 0.1 something, all right? The square root of 10, all right? The square root of 10 is a big, long, ugly decimal. It is 3.16227 blah, 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 blah. It keeps on going on forever and ever and ever. The square root of 10 is an irrational number. So all of these other ones have to be rational. 1.3 is rational, 0 is rational, 9.23 repeating, all right, because I could use a repeating sign, that's rational. 2/5 is rational, any fraction is rational, any repeating decimal is rational, The square root of 0.25. I don't have a calculator in this room that I'm in today. The square root of 0.25, let me just type it in real quick because I need to know what that is. So the square root of 0.25 is 0.5. All right, so this is just 0.5. Square root of 25 is rational, -8 is rational, any fraction is rational, 2 is obviously rational, and 4 is rational. But now we need to classify them even more. So in our next inner circle, we're going to get more selective. These are integers as well as being rational numbers. So 0 is an integer. The square root of 25, that is 5. That is an integer. -8 is an integer. 2 is an integer. And 4 is an integer. So everything that is an integer is also rational. These numbers on the outside here are only considered rational numbers. They are not integers, not whole numbers, not natural or counting numbers. So now we want to get even more specific, and we want to move into whole numbers. So whole numbers are positive. They start with 0. Whole numbers are positive. They start with 0. I'm going to treat 25, the square root of 25, as 5. So I'm going to say that's positive as well. So by classifying them more, 0, 2, 4, and I'm going to call this 5 are whole numbers, they are integers, and they are rational. Now, if I want to classify even more, all right, even being more specific, natural or counting numbers. Natural or counting numbers start with 1. So 2 would count, 4 would count, and I'm going to call this 5. 5 would count. So that leaves these numbers inside, 2, 4, and 5. They're natural and whole numbers and integers and rational numbers. So these are all 4. 0 is a whole number, an integer, and rational. -8 is an integer and rational. And these ones on the outside are just rational numbers. Again, your irrational numbers are your ugly, big, long, ugly, non-repeating, non-terminating decimals.